Welcome everyone to today's webinar. Our moderator today is Nicholas Horton of Amherst College. He's the chair-elect of the section on statistical education and associate editor of Chance Magazine.
Well, Rebecca, thank you very much for bringing us together today. I'm really excited to hear from Andy Ziffler and Michael Huberty about their very innovative course and how that's actually connecting things they're doing at the undergraduate, graduate, and high school level. I want to just remind people there will be an opportunity to have your questions heard and answered, so please go ahead and submit those to the presenters at any time as they arise. I wanted to kind of just also note that the Chance special issue on nurturing statistical thinking before college has hit the internet and is available in printed form. This has a series of articles that are listed here on a variety of topics related to the K-12 curriculum and its interface with the college curriculum. So I'm very excited about these articles and also really appreciative to Rebecca and the education program for getting us together today. So Rebecca, if you want to go ahead and hand over the screen while I do a brief introduction of our speakers. Andrew Ziffler is a senior lecturer and researcher in quantitative methods and education program at the University of Minnesota. He's previously taught AP statistics and now teaches a variety of graduate level courses and supervises graduate students who teach statistics in that program. He served as a PI on a number of research projects, including CATALST, that we'll be hearing about today. He's authored a number of papers, book chapters, and textbooks. He serves as co-editor of the Technology Innovations in Statistics Education and a member of the CAUSE StatEd Research Advisory Board. He's a recipient of the Waller Education Award for his innovative teaching of introductory statistics and his many contributions to statistics education. Our other presenter today is Andrew's colleague and student, Michael Huberty, has been teaching high school statistics, mathematics, and science for 23 years. He also teaches undergraduate statistics at the University of Minnesota and calculus for the University of Minnesota Talented Youth Mathematics Program. He's currently working on a PhD in Ed Psych with a concentration on StatEd. So let me hand it over to Andy and Mike to talk a little bit about modeling and simulation via CATALST.
Thanks, Nick. This is Andy, so you get used to my voice. And I'm Mike. And we're going to talk to you today a little bit about our CATALST curriculum, which we wrote for the undergraduate curriculum and have since started to bring it into the high schools with I think a little bit of success so far. So we'll give you a little bit of background about the curriculum. It was initially part of a 3-year teaching experiment that came out of NSF. And was inspired by ideas by George Cobb, who talked about randomization-based inference at USCOTS in, I think it was 2005, and then wrote about that later in TIES. And we also were inspired by Alan Schoenfeld's ideas that in mathematics that he wished that people learned how to cook instead of just following recipes. And so we decided to bring that into the CATALST course by promoting statistical thinking and trying to teach students to think statistically rather than to just follow ideas of the different tests that one might do. And this is it's a little bit different than one might think of a typical undergraduate statistics course in that we start about day 1 or 2 with statistical inference. And students are immersed in those ideas of statistical inference and modeling. The curriculum has 3 kind of main units to it. In the first unit, students learn how to build probability models, and then they simulate from those models. And they do this in a software called Tinkerplots, which we'll show you a bit of later on. And then in the second unit, we build on those ideas of probability models and introduce models to compare groups. And in particular, we teach them about the randomization test as a way of kind of modeling chance variation and to look whether there are group differences. And then in the third unit, we take that modeling and simulation a little bit further and talk about the idea of bootstrapping as a way of estimating standard error and doing what would be conventionally done in confidence intervals as well. And just some side notes in terms of where things come where the students might normally pick things up. So in a typical course, you might start with descriptive statistics and then kind of carry on through sampling and sampling distributions and then inference. Well, we start with the inference and modeling. Students, we introduce them to ideas of standard deviation, but only as a way of measuring variability, and that comes in Unit 3. So they've done a lot of inference before they even hit descriptive. And part of that rationale was because of the new Common Core and also the Minnesota state standards. We didn't adopt the Common Core, we're one of like a few states who didn't here in Minnesota. But we have descriptive statistics and basically what might be considered a first intro class in stat even in terms in their high school in theory now. The whole course kind of iterates around three ideas that George proposed, and then we've taken and expanded upon a little bit. But the idea that you can set up a model, that you simulate from the model, and then you evaluate the results of some observed data within those simulated results. So two example questions that students might encounter in the course. In Unit 1, they would do simple probability modeling. So they might do something like, we might ask a question like, how many threes would you expect when rolling a die 10 times? And so they would build a model, they would simulate from that model, and then they could answer that question. Later on in the course, those questions might evolve to something more in a comparison of groups type question. Does the effect of sleep deprivation last, or can a person make up for sleep deprivation? And so again, they would model that under the null hypothesis that there's no difference. They would simulate those results, and then they could evaluate what the observed data would suggest within that. And I'm going a little quicker through this first part, kind of the introduction of the course. You can find out a lot more about that in the Chance article if you're interested, and we put a link in the slides here, and Nick also mentioned those in the first part of the talk as well. But one of the main differences in CATALST is that we really use and utilize methods of cooperative learning. So we have the luxury of teaching in an active learning classroom here at the University of Minnesota, and you can see a picture of it there on the slides. And so there are, I think, 9 students per table. Each set of 3 students has a computer hookup. There are monitors all around the room that we can project what's on the instructor computer or what's on the student computers. We have students work in groups of 3 or 4. We do minimal lecture in the classroom, so a teacher might come in and maybe only say something at the beginning of class to kind of orient students, and then at the end of class to wrap things up. But students primarily teach themselves, and the teacher or instructor acts as kind of a guide on the side, maybe helping groups and so on, and leading discussion. We also require a laptop for each group. So that we'll talk a little bit about that later when we get to the high schools, because that's been one thing we've had to work with the high school teachers on. And our goal for instructors is to be navigators, not pilots. So again, we teach with minimal lecture, and the primary purpose, again, of the instructor is to raise questions and to lead the discussion. And if any of you are in Minnesota ever and want to come visit a class, you're more than welcome to come and see the course in action. We made a conscious decision early on to use tinker plots as opposed to using a software that's more traditionally associated with statistics, say like R or SPSS or something like that. And the reason we chose tinker plots was intentional in that the modeling capabilities are really quite visual, and we think that leads to greater student understanding. And so all of the course activities, the homework, and assessments that we wrote for the class have students use tinker plots. And we've played around with using some other software. We had one implementer early on that used R. Jim Albert wrote the whole course in R, and we do have that available as well. Fathom may be suitable, but it doesn't probably have the same modeling capabilities in the visual sense that Tinkerplots does. And one of the big differences that high schools oftentimes use the graphing calculator, and that just would not work for the course at all in our take on it. So we're going to give you a little bit so that you can see what Tinkerplots does. So this is something we can't obviously show in the article, but I wanted to show you today. And so one of the early activities we do in the course has to do with thinking about the reporting of breakups on Facebook. And so a guy named David McCandless, actually, who does kind of InfoViz type stuff, actually got Facebook to give him a bunch of data on breakups and on the day that people reported breakups on Facebook. And so in the activity we use a subset of that data, and we say consider you have a random sample of 50 breakups reported on Facebook within the last year, and 13 of those have been reported on Monday. And so what we want to know is whether that percentage, 13 out of 50, is higher than one would expect just because of chance. Okay, so
this is Mike. I'll take over some of the talking while Andy does some of the demonstrations here. So at this point in the course, as Andy said, really the teacher's being the guide. So the students are really set up with the problem, and within their groups of 3 or 4 students, they're asked to then set up the model through the sampling device within Tinkerplots. And so Andy's got the one version of this, and we'll show you there's a few ways of doing this. And so we've got the sampler device within Tinkerplots. This part is just a mixture where we've got then, the students are just given the blank thing, and they have to figure out what they need to put in the mixer. And so they'll put in their, 7 days of a week. And then from that, we're trying to emulate the, a random chance model of, every day of the week is equally likely. And then to, emulate the fact that we had a study that ran 50 trials of this, or I should say 50 samples. We're running that same thing through. So Andy just ran that. And so it randomly pulled out of the Tinkerplot. In fact, Andy, do you want to slow that down just a little bit? Because he did it very fast, and initially it's very useful for students to see it visually. I think we've got a little bit of a lag here. So you can kind of see where it's pulling out sort of one of the balls at a time. It's one of the days of the week, and then it slides it over into the table. And then, after students get used to what that looks like, then they get bored of watching that in the slow motion and speed it up to fast. But kind of wanted to see that initially we want that very visual representation of how the sampling is working. And so once we have these, a sample of 50, just like in the study, then they'll make some sort of a plot of this. And let's see, so we've got this kind of slowly coming up here. So here's our 7 days a week. And we wanted to know then, based on the original study, how often Monday comes up out of those 50. And so, very quickly we see 12% of the time we got a Monday. And that could be either displayed as, percentage or number. Students can collect it either way for emulating the study. And every time he presses run, it's another sample. And really what we're wanting then is just the Mondays, right? We want to know, running sample after sample, how likely is it that that Monday is showing up various times? Again, we're going back to that original study that it was the data was 13 out of 50. So we want to know, what does it look like random chance? Can we get 13 out of 50 to occur at random? So we collect that data for Monday. This one was 7, and then we're going to run it a whole bunch more times. And he's turning the animation off this time just to speed the process up. But again, you could have it slower if you're really wanting the students to see that visual one sample at a time, which is really good when you're starting the course. Once the students get going on it, they don't want to watch that anymore because it takes a while. And you can kind of see that the screen is refreshing slowly. You're seeing some of these. So it looks like we've run 101 of these. And now we can plot these results of the 101 trials. So you see everything's very much a drop and drag, very visual approach using Tinker plots, which really works well for the students that we have in the course. And now we're wanting to look at, okay, how often did Monday come up? And so we're putting the divider up here, looking at 13 days out of 50, because that was the original study. And then students can, they could either count these themselves, or Tinker plots can put on a percentage, and we see, well, there's the one dot of the 101, the divider showing 1%. And so at this point, they've got a little sense of this is their level of support for that null model. And so we're saying, okay, but, their interpretation then is, 1% out of the 101 times here, we were able to get this to occur. And, have them discuss how likely is that to have occurred by chance. And, so this is their idea of p-value. We have introduced p-value at this point. This is about week 4 in our 14, 15-week course. Let's see. So they're able then to say, well, this isn't likely to have occurred by random chance. So most of them will conclude that, yep, something must be up about Mondays. And they may theorize different reasons for that, but that's kind of where we want them to be at. Now, initially, this, we showed this using the mixer with the 7 balls, one for each day of the week. But really, when we do this in class, different groups come up with different ways of setting up their model. And so some of them will set it up as, the middle model here, each day of the week, as a percentage in that pie chart kind of thing. It works the same way. So they just have to set it up as, 14.28% each. Others realize that, it doesn't really matter what day of the other days of the week. They only care about Monday versus not Monday. And so a couple of groups will set it up that way. It's Monday versus other days. And it's just a simpler model to do. And, in fact, one of the challenges we'll give students and groups that might be finished a little earlier than others is, hey, you've come up with one model. See if you can set it up with a different model. So it gives them some different ways of thinking about things.
So it also allows them to check out robustness of results to see if, they actually do produce the same type of results from different models, which is kind of nice for them to see.
So, as Annie mentioned before, in Minnesota here, we're under Minnesota state standards, which aren't in the Common Core cohort, but we do some similar things, and we put in the article some of the connections with the Common Core. Specifically, the big one with us is the making inferences and justifying conclusions. That's really big, and in fact, that's what we do all the time. As we said, the whole idea of doing these inferences, we're doing these right away in the course, throughout the course, rather than some of the more traditional ways of doing introstats with a lot of the descriptive statistics. But we do have some of that descriptive stuff in there, but really that's the big one. The mathematical probability theory, we really don't address that very directly other than through this idea of our simulation. And they get used to these ideas of sort of probability in that sense, but it's not a big theoretical thing of, working with, intersections and unions and things like that. So it's not a sort of a math theory kind of situation.
We should probably mention a little bit of ways, as we're starting to transition into the kind of catalyst in the high school, is how this relates to some courses that already exist there. And we don't believe that Catalyst is a replacement for AP statistics. Some of the ideas from Catalyst could probably be easily brought into an AP statistics class, and I think actually Mike has done that in his high school teaching. But it's just not a good replacement for the AP curricula, probably. The AP is quite different. They spend a great deal of time on the curriculum and on descriptive statistics, probability models, survey design, experimental design, and Catalyst doesn't really touch on that at all. Also, since they have to take the test at the end of the day with a calculator, and we use Tinker plots. That just isn't a feasible replacement at this point. So I think it could be brought in, but the one thing we've really seen, and Mike will talk about this a little bit when he talks about how we've implemented this. He was one of the early implementers in Mounds View High School here in Minnesota, and it is a really great class for those students who may not be AP ready, but don't want to go on and take, pre-calculus or something like that. So we've seen it be a really nice fit, and Mike can tell you a little bit about that, how that played out in Mounds View High School.
So I've been teaching at Mounds View High School for, I guess this is my 18th year. So 4 years ago, Andy and Joan Garfield mentioned to me of, hey, is anybody interested in piloting these new materials for Catalyst? And I quickly volunteered. So I ran that 4 years ago for a one-semester course, which is fairly similar to what we have now. It's certainly been improved upon in that time. But what was really kind of neat is I taught an intro stats prior to that, and so we had the opportunity to jump right into this at Mounds View. And at the same time, we also have an AP stats course, which I taught, but that year I wasn't teaching AP stats. And so it was kind of neat that the teacher next door to me, as we were going through the curriculum, he was teaching the AP, and I was teaching the intro stats with the Catalyst materials. It was kind of neat to see what the students were learning, and certainly at very, very different times. Certainly these students who are, as Andy said, they're not generally AP ready. Some of them probably could have, but they didn't want to. And other students, I will say, really had not been successful in math courses in the past. And so to give them an opportunity to actually do some stuff that was very, very activity-oriented, very kind of hands-on for them, it really changed the way some of the kids thought about math. So what was really neat is so early on in Catalyst, they're at this idea of making inferences and interpreting p-values. And so, this is happening in really at the high school. I had a little more time than we do at the university level. But probably in, the second month, the kids were interpreting p-values and in the Catalyst course. And of course in AP Stats, which we have as a year-long course, they get to that, March, maybe February, March. So the other instructor who's teaching AP Stats was just amazed that here we have the students who have sort of been viewed as not being able to do sort of the higher level stuff. They're able to do these inferences. And this teacher I'm referring to is named Dan Butler. He last year then taught the Catalyst curriculum and also had amazing success with kids who have not been successful in the past. So it's been a really exciting thing to watch in the high school level of success in students who haven't had that kind of success in math courses in the past.
So as Mike was saying, the Mounds View was the first high school to kind of adopt Catalyst and try it out for us. And since then, we've started working with a program here at the University of Minnesota called College in the Schools, where our courses here at the university are taught in the high schools by high school teachers under direct supervision from the university staff here. And this is our first year doing it. The enthusiasm was crazy. They actually told us, you probably won't have more than about 4 or 5 schools maybe in your first year, and we have something like 12 or 13. There might be one that dropped out since this, but it's a really interesting and unique experience. A lot of these high schools are using Catalyst as that third year of mathematics. We require three years in Minnesota, and that third year has been kind of tricky. So a lot of these schools want to adopt Catalyst to kind of fulfill that need, but then they also get University of Minnesota credit. And they take the exact same tests that our university students do. They do the exact same homeworks, exact same quizzes, everything like that, and are graded in the same way. And that's what we work with the high school students high school teachers to do. We also do workshops with the teachers and have some ongoing professional development that we do. We want to give you some time for questions too, and so we'll wrap up by offering some resources and materials if you're interested in doing this. All of the materials we use are available for free online, and you can get the whole book that we use in the course on GitHub. There's an address there. We also put up lesson plans and some other resources. We put up the website here for TinkerPlots. I think TinkerPlots is fairly inexpensive. I think a year-long license is like $7. Yeah. So, and then we also put our email addresses here if you have further questions as well. But I think we'll open it up for questions.
Great. So please take a minute and send us some questions. Just go to the chat window under presenters. I have a couple of questions that have come in. One, is asking about this relationship between the Common Core state standards and the Minnesota state standards, which sound like they are somewhat similar, even though it's not under that same framework. The question is, TinkerPlots seems to build a whole modeling approach to understanding, kind of building a model and seeing how it progresses. We saw that as with the three different models that you presented that students might use for the Monday versus other days or weekday versus weekend. Could you talk about what relationship there is, if any, with those modeling standards and how that might dovetail with TinkerPlots and the CATALST curriculum?
I would love to. I'm not as familiar with the Common Core standard since we don't use it here in Minnesota. But my guess is it would come in pretty well. The model we showed you in TinkerPlots was very simple. So you can build up conditional models quite easily, actually. And I've actually thought about playing around with doing some Bayesian modeling in TinkerPlots. But yeah, so I think we've got the high school modeling standards up right now. And my guess is that you could use this to illustrate a lot of these, what we're seeing here. So I think that'll be my answer for now, Nick.
Okay. That's great. Got another question. How many lessons are involved in your course, and would this be a year-long course for high school or just a half-year course?
That's a really good question. At the University of Minnesota here, the course is originally set up for 14 to 15 weeks where we meet twice a week for 75 minutes. So really that's how many lessons we have. But at the high school level, the high schools often, some of them might be 50-minute classes, meeting every day for a semester. Some might go a whole year. Some will be on block schedules, which might be 80, 90 minutes a day. So we've got a lot of variety. I know with the college and the schools teachers, there's a lot of variety within those as well. What's really nice teaching it at the high school level is because we meet every day for a semester, now we've got 80 to 90 days of class time rather than 28 days, even though it's longer per day, for example. So I had a lot more flexibility. I had a lot more time to do some discussions. I had a lot more time to do additional activities. In fact, there's a lot of activities now that we're in our third edition of the CATALST materials. There's a number of things that have sort of been trimmed from the curriculum to keep it for the university level sort of schedule, but we do have a number of other activities that can be put in for supplementing. As Andy mentioned, some conditional modeling with TinkerPlots. We've got some nice activities for that.
And I think a lot of the college and the schools teachers, too, are using some of the time in class to do what we would maybe have university students do outside of class.
Yeah.
And just because of the accessibility issue with computers and some of that. So they're coming up with some unique solutions, but I think they're making use of the time that they have as well.
So when I teaching at the high school, the CATALST, I rarely gave students homework. They were able to do all the activities in class, and I would give them, some reading or some videos to watch outside of class. But I really never gave them any activities that they had to do outside of class. We had enough time.
Great. So there's a question about TinkerPlots and whether whether it's possible, anecdotally or in a more kind of formal way. Can you characterize the experience of students who work with Tinkerplots in Catalyst and then move into your second course? Are they able to proceed and translate from one system to another, having understood the concepts?
My response to that is yes. It's just like anything else. There's maybe a little more startup cost initially once they move to another software, but it's like, if someone learned in Minitab and then had to switch to R, I don't think it puts them that much further ahead, to be honest. But what we suspect, we haven't done any kind of retention and follow-up studies that far down the road. And most of our students, to be honest, are probably one and done in terms of courses. They take this class, most of them are social science majors of some sort, and then maybe they take another stat class in graduate school. But our perception is that they have a much deeper understanding of inference, so they don't have to work so hard on the understanding of content later on, so they could focus that time on learning the software. So I think it's pretty translatable. And if you have a visual depiction of a model, that makes doing simulation when you're writing for loops or something like that just that much easier as well.
Great. Another question: you both taught extensively at both high school and the college and graduate school level. Can you talk a little bit about this really explicit focus on active learning is kind of one of the hallmarks of the Catalyst course. How does that compare to what kind of is happening, at these schools or at other universities you've taught at? Is that kind of like in the norm now? Is that helping to push the envelope for more active learning?
So I can let Mike tell you a little bit about his experiences, but I can tell you what I've seen with we've got an ongoing kind of Google chat going on with our college in the schools. We've got a Google group where we continuously talk with them about what's going on. And so this is very new to them, and it's pushing the envelope in terms of how they teach classes. But what we're seeing is spillover into their other classes. So they're using discussion and Catalyst because they have to, and then they like it, and they're learning kind of how to teach in this Catalyst way, for lack of better terms, and it's carrying over into their other classes in what we think is very positive ways. But it definitely goes against maybe what they grew up learning from, and also how they've probably taught in the past. So it is pushing things a little bit.
I think I've always kind of taught as much as possible using activities and getting students involved. I actually started as a science teacher, so I think that part of that background has always been there, doing experiments. So for me, the Catalyst was a natural. This is what I do when I teach my AP stats, when I teach, pre-calculus. This is how I teach for the most part. But so when I get questions like this, it's always a little. I forget that that's not how most people do teach and experience things. We sometimes do get feedback from students of, hey, can't you lecture more? I want you to tell me. So we do get that sometimes, but certainly the research bears out that, hey, this is the best way to learn.
And we're very upfront with the students at the university level that this is how we're going to conduct the class, and that you are going to teach yourself, and that it really is a group effort. And if that's not your forte, then maybe a different class is a better option. So we try to filter quite a bit at the university level. And I think the high school teachers kind of handpicked this year their college and the school students. So and then hopefully word gets out of what it's like, and I think students kind of self-select in as well. That's what we're hoping.
Great. Well, I want to thank you both for a really interesting presentation, a very provocative course that I think is helping to kind of move the envelope for all of us at the high school and at the college level. The resources and materials that we have up there right now are a wonderful trove of things for the community. So without any further ado, I want to thank you very much for taking the time for this and to kind of letting us know about the Catalyst course and materials. Thanks.
Yeah, appreciate it. Thank you.
Thank you, Nick, and thanks to everyone who participated.
Well, thank you all so much for joining us today. I'm going to go ahead and close down the webinar, though we will be posting it online at both the CHANCE website and the K-12 Statistics Education webinar site. Thank you so much.